Yeah, in this video, we'll see the loading the labels data into data frame. Let's move forward. After loading the required libraries, the next step would be the loading labels data into data frame and viewing them. So if you observe here, the data set is loaded in the folder doc data set. Under this, we have test and trained data, and we have labels data, labels.csv file. Now, read the label.csv file and check the shape and records. Labels underscore all equal to pd dot read underscore csv. So I'll take this path labels.csv file, copy the path and paste here, and then print labels underscore all and just print this one, labels all dot shape, and then labels all dot head, and let us run this. So here we can see that there are around 10,222 rows and 2 columns. The column names are ID and breed. So let us visualize the number of each breed, that is the value of each breed. Visualize the number of each breed, that is the value of each breed, that is the value of each breed. So breeds all equal to labels all breed. Now I'm going to count the breed count. I'm going to define a variable breed underscore counts is equal to breeds all dot, I'm using the function value count, value counts. And the top records I'm going to display breed counts dot head. First 5 records I'm going to display. Let us run this. So here we can see that different breeds like Scottish Deerhound, Maltese dog, Scottish Deerhound contains 126, Maltese dog contains 117, and so on. So the total count per each class can be found out using the value function. As the data set is pretty large and due to computational power, what we will do is we will select only 3 breeds for this classification. So here you can see that I have a new class, new list as a class names, and I will pass only 3 classes of. Here I'm going to use 3 classes, selecting the first 3 breeds. class names is equal to, I'll just copy this breed and then Scottish Deerhound and Maltese Dog is another breed. And I'll take Bernese Mountain Dog, which count is 114. So next step is labels is equal to labels all of breed dot is in the class name so labels is equal to labels underscore all of labels so labels underscore all of breed dot is in class names. Yeah. So the next step is labels is equal to labels dot reset index, and then I will take labels dot head. Let us run this cell. Yes, this command is executed successfully. So you can consider more of these classes as per your system's computational power, and we have selected only the required classes. So we have labeled our data set as per the classes of dogs. We have selected, and we will work on these three classes, that is Scottish Deerhound, Maltese Dog and Bernese Mountain Dog. So this data is a classification data set. So we need to encode the target value, that is the classes of the dogs. After that, we will read all these images and convert them into Numpy array, because we need to normalize them. So the next step is we are going to creating Numpy matrix with zeros. So for this I'm writing x data is equal to np dot zeros of length of labels. comma 224 by 224. Since it is a color image RGB, I'm going to write 3 comma data type equal to flow 32. So this is the X data. We are creating a Numpy matrix with zeros in it. Similarly, let us run this. Yeah. Similarly, we have one hot encoding on Y data using the label binary function. So the next step I'm going to do one hot encoding. I'm going to take Y data is equal to label binarize of labels of breed classes is equal to class names. Let us run this cell. Yeah, it is executed successfully. The next step would be reading and converting the images and normalizing it. So as image pixels ranges from 0 to 255, in order to normalize an image, we divide that image with 255. So now reading and converting image, reading and converting image into Numpy array and normalizing data set. For that, I'm going to write the following code. For I in tqdm of range of length of labels image variable img is equal to image dot load image, where all your images are there in the folder dog dataset under the train. So what I will do, I'll take the path I'll copy the path in the previous content. Dog dataset is the directory. Dataset slash under the folder train. I'll see with the ending s.jpg images matching with s. Percentage labels id of I, comma target size is equal to 224 comma 224. Now the next step will be image is equal to image dot image into array, image to array function I'm writing, image to array of the image, and x equal to numpy dot expand dims. I'm using the function expand dims image dot copy, comma access equal to 0. X data of I equal to x by 255. Now let us run this cell. So now we are converting the image into NumPy array and normalizing the data set. Executed successfully. After that, we will print the train image and the one-hot encoded shape and size. So for that, what I'm going to do, printing train image and one-hot encode shape and size. Print \n train images shape x data dot shape comma, if you want to size will be dot format x data dot size. And the next step, I want to print one-hot encoded shape that is y data dot shape, and size will be dot format of y data dot size. So now let us run this cell. So here we can see that the train image shape, which is 357, that is the total number of images, and the size is 224 by 224 by 3. 3 is the channel, that is RGB in this case, because these are the colored images, and the sizes as 53, 738 and 496. Similarly, the one-hot encoding shape, it would be 357 as the total number of images, and 3 because we are considering only 3 classes. So in the next step, in the next session, we will see how we can build the model for it. The total size would be 1071. Thank you.